In this video, let's talk about conditional probability and independence. And when we talk about conditional probability, this is a special type of probability that occurs when you know something has already occurred. So if we have that, we can start talking about this concept that we call independence. So today, your learning intention is the student will explore independence through conditional probabilities. All right. And here are your success criteria over here. And we should be able to, the main one we want to be what we call independence. So we're going to start off with the example that we did earlier in class where we talked about the OkCupid data set. And then we looked at two variables on males. It was either they were tall or short, or so there's a height variable, and then the other variable was that it was either a high income or low income earner. All right, and so remember we did this, we called the taller male, the taller than the median male, T. And we're gonna call the shorter male, T, C. And remember the C means not, so you have not tall, you have tall and not tall. And then for the other one, we called this one the high income earner, we called them H. And we're going to call somebody that makes less than the income or less than the median income, we call them HC. And so now what we're going to do is I want you to notice that there is an unusually large number of high income earning tall males in this sample. There's only 192 people in the sample to begin with, and of those 192 people, 101 of them are high income tall males. So what that leads me to believe, and this is a dating website or dating data set they're talking about. So when guys start to date, they lie. So you have some males that are going to lie and tell you that they are tall and they make a lot of money, basically. So I want to see if that's actually true. Or what I really want to explore is your height independent of your income? And the way I'm going to do this is what we call the conditioning. So the first part of this is I want to look at, given that a man says he is tall, what is the probability that he earns more than the median income? And the key word here is this given word, because this means I'm looking at a different type of probability. And if you come over here to this side, we're going to talk about what's called the conditional probability. And a conditional probability is the probability of an event occurring, which means that given something has occurred. Given that something has occurred. So conditional probability is the probability of an event occurring given that another event has already occurred. And we write it as the probability of B given A. So we write it as the probability of B given A. This is what we call the conditional probability. It's B, and this bar right here means given A. And what this really does is it's going to restrict everything in the sample to a particular thing. So we come back over here using our variables. We always said, I like to write the given first. I'll write it as a probability of, given that a man says he is tall. So the given part, the part after the bar, is that he is tall. What is the probability that he earns more than the median? So now we're interested in the people that are tall and they have to earn or be a high income earner more than the median. And so what I'm really doing is now I'm restricting this sample to people who earn more than the median. To people who are part of the given. In this case, given that a man says he is tall. So I don't care about all 192 people anymore. I only care about all of the tall people. I only care about these 123 people. So what I've done is I've restricted the denominator of this fraction to 123. And out of those 123, I'm only interested in those high income earners, which is 101. And that's how we literally find the conditional probability. The notation is probability of B given A. The formula for probability of B given A looks like this then. If we take what we just did, the probability of B given A, and look at it, it works out like this. The first thing you're going to do is you're always going to restrict to the given part. So we restrict the denominator to the given part. So just like this, we're restricted to all of the tall people. We're going to restrict to whatever A is. Now, you write that just like this. This is the probability of A at the bottom. Right? And then the next part is, once you have it restricted, you want to see where do these things intersect? Where do these two events intersect, A and B? And in our case, we had H and T. They intersected right here. Remember, the intersection is just this right here, the probability of A and B. So for this particular question, and we go back to look at the OkCupid data set, who are we restricting the sample to? Well, I'm going to restrict to all tall men. That's what I'm interested in, all the tall men. And then based on that, will every man go into the sample? Well, no, not every man will go into the sample. As a matter of fact, only the 123 tall men will go into the sample. And out of those 123 tall men, I want to know who is tall and a high income earner. So this is an introduction into conditional probability. And it's a very simple concept. But what it says is that if an event already has occurred, now that this event occurred, what's the probability of another event occurring?